All right, in this video, I'm going to be talking about factoring quadratics. I'll begin talking about it, I should say. I'm going to basically recap how to factor quadratics, and I'll share some tips and tricks, whatever you want to call it, based on my experience from helping students who really struggled with factoring. If you're an honor student and you're watching this, I would expect that, especially for an honor student, you should be able to factor a certain subset of quadratics, the easier types, which I'll go over, within 15 to 20 seconds. If you're non-honors, I would expect within 30 seconds. All right, that's like a metric to kind of figure out if you're competent or not. If you're spending a minute on the easier ones at first, that's fine, but hopefully you're practicing enough such that you get faster and you can reach that 30-second maximum or 15 to 20 seconds if you're in honors. All right, let's begin. I'm not going to go over a lot of examples. These, to be honest, you have to just practice and get a feel for it for yourself, struggle with some of them yourself. And when you struggle, in my opinion, you have the best retention because you don't want to make the same mistakes next time. All right. So this is part one. So we're going to focus on, so this is the standard form for quadratic, ax squared plus bx plus c. We're going to focus on a equals 1. C is positive, so greater than 0, and B is either positive or negative. Okay. These types, for sure, if you're in honors, you should be able to do in 15 seconds. All right, before that, let me explain why we factor. Besides learning an algebraic technique that can help in simplification, an application for it is we can easily find the zeros of the quadratic or the roots of the quadratic if we factor. So first of all, if we have this factored form here, x plus 2, x plus 3, how do we expand it out? We use the FOIL method. First, outside, inside, last. That's what FOIL stands for. So first, x squared, outsides, 3x, insides, 2x, last, 6. Yeah, remember that? So then you simplify this to x squared plus 5x plus 6. This is in the standard form. So the whole point for factoring is going the other direction. We want to go from this expanded form, standard form, into this factored form over here. Okay. And again, I was saying this factored form is nice to find the zeros as a function. It's called the zero product property. You already learned that. I'm not going to go over it in this series, but that's one big reason why you learn how to factor. Okay, so what's the general procedure? The procedure is always the same no matter what. There's a nuance when a is not equal to 1, but I'll go over that in part 3. All right, but for parts 1 and 2, the easy types, the procedure is always the same when a equals 1. You want two numbers that multiply to c but add to b. That's it. That's the simple procedure. Okay, so you have to be able to think of two numbers yourself. I can't help you there. Your teacher can't help you there. You got to think independently. Two numbers that multiply to c and add to b. Okay, so for example, in the same quadratic, x squared plus 5x plus 6, how do we know that we can factor to x plus 2, x plus 3? This is the procedure. You want two numbers that multiply to 6, positive 6 specifically, and the two numbers need to add to positive 5. And what two numbers do that? That's 2 and 3. So you write it as x plus 2, x plus 3. Positive 2, positive 3, so positive 2 here, positive 3 there. Okay? Let's do a few examples. And then during the examples, I'll give some tips to help speed things up. Again, these tips come from me helping students that really did not think for themselves. They just kept guessing and checking and all that. Okay. Example 1. X squared plus 7x plus 10. We want to factor this. So procedure, where two numbers multiply to 10, but add to 7. So let's just list out all the choices for the sake of showing how to do this, okay? What two numbers multiply to 10? Integer numbers. We have 1 and 10 and 2 and 5. That's it, okay? So I listed them all out here. 1 and 10, they multiply to 10, but what's the sum? It's 11. That's not 7, right? So it can't be that choice. What about 2 and 5? They multiply to 10 and they add to 7. So this works out. The two numbers that we want are 2 and 5. So how do we write the factor form? It'll be x plus 2, x plus 5. Okay, like that. Okay. Example 2, x squared plus 10x plus 16. We want two numbers that multiply to 16, positive 16, and two numbers that add to positive 10. Let's list out all the choices again. 1 times 16 is, sorry, this should be probably copied and pasted. This should be 16 as well, okay? 1 times 16 is 16, but 1 plus 16 is 17. That's not 10, yeah? So we move on. 4 times 4 is 16. 4 plus 4 is 8, though. That's not 10. So cross that out. I really did not finish this, it looks like, sorry. And then 2 times 8 is 16. Yeah, 2 plus 8 is 10. So the two numbers that we want are 2 and 8. Once again, two numbers that multiply to 16 and they add to 10. 2 and 8 works. So we write it as x plus 2, x plus 8. Okay, so you see, you have to be able to think about those two numbers for yourself. No one can help you there. So you got to be able to do that independently. All right. Another example, listing out all the possibilities. We want two numbers that multiply to 36 and add to 13. So what are the possibilities for two numbers that multiply to 36? Is 1 and 36, 2 and 18, 3 and 12, 4 and 9. Yeah? There's also 6 and 6, but I didn't write that here. Okay? But you can see when the numbers get bigger, there's likely more choices. Okay, so I'll start giving some tips as to how to not go through every single possibility. I didn't even write the 6 times 6 one here, but you can see this is getting to be a lot of possibilities that you got to check. 1 times 36 is 36, but 1 plus 36 is 37. That's not 13. 2 times 18 is 36, but 2 plus 18 is 20. That's not 13. Keep moving on. You finally get to that 4 plus 9 is 13, and 4 times 9 is 36. So the answer is the two numbers that we want are 4 and 9. So the answer is x plus 4, x plus 9. Okay, so now, in the next example, let's start thinking a little more critically. Okay, we got to think for ourselves instead of blindly following a procedure. Okay, so x squared plus 4x plus 18. We want two numbers that multiply to 48, but add to 14. Okay, so let's just pick one pair, like 2 and 24. Okay, 2 times 24 is 48. I know that 2 is a factor because this is even, so let's just try that. 2 times 24 is 48, but 2 plus 24 is 26, okay? Notice here, instead of blindly picking the next two numbers, let's notice that this sum is too big, okay? So what if we pick two numbers that are closer to one another, okay? If they're closer to one another, the sum doesn't get as extreme, okay? If you don't believe that, let's look at the next choice that I picked. What about 4 times 12? That's 48, right? What's 4 plus 12? That's 16. Yeah? 16 is not 14, so it's not these two numbers. But look, these two numbers are closer to one another. Yeah? Their sum is not as big. Look, okay? So the sum is still too large. So let's pick two numbers even closer to each other. Okay? What's another possibility? 6 times 8 makes 48. So 6 times 8 is 48. 6 plus 8 is 14. So that works out. It matches sum. Yeah? So look, once again, the takeaway tip, if the sum is too large, pick numbers closer to each other. Sum is too small, pick the numbers further from each other. Okay? And then the answer, I skipped this line, is x plus 6, x plus 8. Okay? That's the takeaway tip from this problem here. Okay? One more. Example 5, y equals x squared plus 26x plus 168. You can see this is a bigger number now, right? So what two numbers multiply to 168 and add to 26? Okay? Well, this is even. Maybe let's do a little better than just 2. Okay? This is another pitfall that a lot of students do. They try 2 right away because they see that's even number. Okay, so let's do a little better than that. Let's be a little better with our multiplication. We could do 8, for example, because 168, well, this 16 is clearly divisible by 8, right? And then this 8 is divisible by 8. Yeah? So it'll be 21 times 8 is 168. Okay, we got to be good with our mental math there. 8 times 21 is 168. What's 8 plus 21? That's 29. The sum is too large because we want a sum of 26, right? Let's pick 2 numbers closer to each other. Okay? Now, people might get stuck because is 9 a factor? 10 is not a factor because it doesn't end in 0. Is 11 a factor? How do we pick the next factor? Okay? And then if they're totally lost, they'll start doing some long division on the side of their paper. Total waste of time. This is a tip of how to pick the next factor. Okay, and again, I've seen students do this. They stuck with picking the next factor, so they guess that maybe 9 is, so they go do it on the side, long division on the side. Maybe it works, maybe it doesn't. If it doesn't work, they pick the next number, like 11, because they know 10 doesn't work. And that's crawling. We want to walk. Okay, so here's a tip to make pick another factor. Okay, that's bigger than 8. And we want them to be closer to one another, as we were saying. The 2 factors to be closer to one, as we were saying up here, because we want the sum to be smaller, right? Here's the tip. We got to use the fact that multiplication is commutative. Remember what that means? You can switch the order of stuff. Okay? So 8, we can break up as 4 times 2. 21, we can break up as 3 times 7, 8 times 21, the one I took up here, okay? And then we can use the fact that multiplication is commutative. We can swap the terms around, move the order. So instead of 4 times 2, and then times 3, and then times 7, we can do 4 times 3 and 2 times 7. Like that, okay? So another factor is 12. Another factor is 14. That's how we can pick new factors instead of doing long division. This is how we think critically. This is how we walk instead of crawl. I keep saying this recently, okay? And what's the sum of 12 and 14? Oh, look, it's 26. This should be 26. Typo. Should I check my work? My bad. Okay. So this, again, is a big tip to pick new factors. Don't do long division. Just break these bigger factors up into smaller ones and then combine the smaller factors to make bigger factors. Use the fact that multiplication is commutative to help you out, okay? So we can write the answer as x plus 12, x plus 14, okay? All right. We're like 60% through part 1. We got to continue. So far, we've been focusing on B and C being positive, and A is 1, okay? This is the concepts I want you to take away, okay? When C and B are positive, let's think about it. The 2 numbers need to multiply to a positive number. C is positive. They need to multiply to a positive number. So the 2 numbers can be both positive or both negative. That's what I'm saying here. Because the product of 2 positive numbers is positive, and also the product of 2 negative numbers is also positive, right? So that's the possibility for the 2 numbers. But we know that the 2 numbers must be positive. They both must be positive because the sum must be a positive number as well. Okay? Think about it. Hopefully that makes sense. I'll say it one more time. When we have 2 numbers that need to multiply to a positive number, the 2 numbers need to be both positive or both negative. That's the only possibilities. You can't have one that's positive, one that's negative. Product will be negative then, yeah? Okay? So we have 2 choices, and we could reduce down to 1 choice because the sum of those 2 numbers must be positive. Okay, so the 2 factors, the 2 numbers that we pick must be positive. Okay, now if C is positive, but B is negative, again, the 2 numbers need to multiply to a positive number, that's C. So they must be both positive or both negative. Now this time, the sum must be negative. So the 2 numbers must be negative. We eliminate the other possibility. So the factor form will be in the format x minus something, x minus something, versus I think over here, in case 1, it's x plus something, x plus something. So again, if we spot that these 2 signs are positive, it'll be x plus something, x plus something. Look, it's always been like that here in the first 5 examples. Yeah? Now, if just b is negative, but c is still positive, you'll have x minus something, x minus something, okay? That's how we can already know if we did the two numbers process, finding two numbers process correctly or not, okay? That's one way to check, I should say. So for example, x squared minus 7x plus 10, okay? We want two numbers, the procedure is exactly the same though. Two numbers need to multiply to positive 10, but they add to negative 7, okay? So again, the concepts one more time. Since the two numbers multiply to a positive, they must be both positive or both negative. They add up to a negative number though, so both of them must be negative then, okay? That's the concept. All right, so now back to finding the two numbers. What two numbers multiply to 10 and add to negative 7? So they both must be negative, yeah? So what two negative numbers multiply to positive 10? Like negative 1 and negative 10? But the sum is negative 11, so not right. How about negative 2 and negative 5? That's it. That's correct. So our factored form is x minus 2, x minus 5. Again, because it's minus here and the plus here, there should have been two minuses here because of the two negative numbers we found. Okay? All right, example 7, x squared minus 19x plus 60. We want two numbers that multiply to 60 and add to negative 19. So let's start picking. Maybe 3 and 20, negative 3 and negative 20, I should say. Okay, they multiply to 60. They add to minus 23. Okay, the sum here is 2 negative, right? Versus minus 19 versus minus 23 is more negative than we need. So let's pick numbers closer to one another. Remember that tip? It works in this case as well. It's just that these numbers are negative, okay? So we want two numbers closer to one another. And it's quite close, right? 23 versus 19. Yeah? So maybe let's try 4. 4 and 15. They make 60. Negative 4 and negative 15, I should say. They make positive 60. The sum of them is negative 19. Works out. So our answer is x minus 4, x minus 15. Okay? Notice how I was presenting this. I was thinking in terms of positive numbers, actually. Okay? And that's my next tip. We're going to revisit the same example, but let's think in terms of positive numbers instead, because a lot of students don't like thinking negative numbers. Even my preferences, I like thinking positive numbers. Okay? So this is why I introduced the concept that we know the final answer must be x minus something, x minus something, okay? Because this is a negative, negative b, and this is a positive, positive c, okay? So if we just remember that, keep that in the back of our mind, okay? We can think in terms of positive numbers instead, okay? Notice over here I did negative, like negative 3 and negative 20, and negative 4 and negative 15, right? What if we just think positive? 3 times 20 is 60, sorry. And then 3 plus 20 is 23. And then 4 times 50 is 15, sorry, is 60. 4 plus 15 is 19, yeah? Let's realize that 4 plus 15 is 19. And then negative 4 plus negative 15 is negative 19, just a sign difference, okay? So if you don't like thinking in terms of negative numbers like here, you can just think in positive numbers, and that's fine for this type of problem, okay? So once again, we can think in terms of positive, yeah? Decide the two numbers, and then just put them in the minus signs here, okay? Again, I've seen students struggle thinking negative numbers, so then this is a alternative way to think about it, if that helps you out. Okay, that's it for this video. Hopefully it was not too long, but hopefully you got something out of it. In part 2, I will talk about, I can just show you right away, where C is negative. We focused on C as positive in part 1. We're going to focus on C as negative in part 2. So hopefully I see you in that video as well.